Hello everyone, New at Games here with another video in the tutorial series of remaking the core version of Getaway, Shootout in Unity. In the last video, we focused on actually getting these power-up boxes into the game, and these are the icons right here, which a player without a power-up can go and collect a power-up, which in this case is just weapons right now. And then with the power-up, the player can use power-up buttons to actually fire the power-up. So that's what you see now. And the system works, but as we'll see, I'll just show some quick fixes for some bugs that I introduced. But in this video, we'll be actually focusing on getting the power-ups, specifically the weapons, to orientate the gun to the nearest player. Because this is what I do in the actual original Getaway Shootout game, is it's nice just for weapons to automatically target the nearest player. That way you don't have to kind of move your player around to get it to orientate the weapon correctly. So that's what we're doing today. But first, let me just get some quick fixes for some bugs that have been introduced in the previous videos. The first one being, as you can see there, is if the player dies with the power-up, the player can't pick up a power-up until that ragdoll with the power-up disappears. And this is simply because the player's not resetting that power-up component. And we just have to go into the script and actually reset that script to no longer hold that power-up. So I'm just gonna go to the player scripts and open up that player power-up and just reset it's just this controller variable to null on disable. So that's what I'm just gonna do here. And setting controller to null. And again, this is because we're doing this ragdoll system that actually just disables this object and re-enables it on spawn. So we have to make sure that all variables that we want to be reusing get reset before we respawn. So that's one bug that needed to be fixed. The other one, as I'll show right now, is with raycasting. So if the player jumps around a power-up box, you can see that it can actually jump using the power-up box collider to actually jump on top of it. And this is something that we don't want. We want these power-ups to kind of be transparent, and we shouldn't be able to jump from them. And this is actually a really quick fix. We can just actually make the power-up box ignore all raycast, and that's simply by changing the layer of this power-up box. And if I just click ignore raycast and change all children, this should make this layer completely, or this game object, ignore all raycast, which is what we want, because then this will also ignore the player gun, and the player will be able to shoot through it. And just thinking about that now, we also want to apply this to the death zone. Same thing, this is a trigger, and we don't want to actually be able to jump on this collider or shoot at it. So I'm going to change this to ignore raycast as well. Okay, that's the second bug. And then just a final bug that has been in this code for a while now is when the player dies, the orientation of the player doesn't remain the same. So if I orientate my player to the left, when it dies, it transports to the right. And this is just because we haven't set it in our ragdoll to actually translate that direction of the player. So I'm just gonna change that by going to this player class and making sure the ragdoll has the same orientation. So we create this ragdoll, call it R, and then I'm just going to set the scale of our, it's our first child, so I'm going to get the child transformed back to child 0. And I'm just going to make sure that the scale is the same as our original object. So this is just our transform. This is our object. And same thing, we just get the scale, and we're setting it to the ragdoll's object. So now both the ragdoll and our object should have the same scale when it's created. And I guess I should explain the reason why I did getChild0 is because we're not changing scale on the parent root object, we're changing it on this body object. So we just have to make sure this body has the same scales. Okay, so that should be those just small bugs that kind of have added up over the videos, and those should all be fixed now. And then the next thing I want to do is actually what I was mentioning at the beginning of the video is to actually get started on the player target system. And with the player target system, the idea that I'm thinking through is to actually make it a little more generalizable than that original Getaway Shootout game, and to actually have any object that you want to be target actually contain a class named Targetable, so the player can then target it. So it's just not the players that are being targeted. We could actually add it to other objects as well. So the first thing to do then is to make this targetable class that I'm talking about. And this will be any object that we want the player to be targeted, or that, yeah, the player that can target. So I'm going to jump to my scripts folder and make that class. So I'm going to go scripting and name it targetable. So I'm just going to open this up here. And like again, so this is going to be any object that is targetable. And I'll just create some variables for this object that will be useful to kind of just know if it should be targeted or not. And the first one is just a float, and I'm just going to call this a range. And the idea of this is the maximum range of when it can be targeted. So if you're outside the range, don't target this object. The second variable I'll add is just like another float, and I'll call this priority. And the idea of this is objects with higher priority should be targeted more than objects with lower priority. So I'll just give that a default value of 1, and also I'll give a default value of the range of like 20. And then I'll add actually another variable here, and I'll call this the offset. And basically, we want this player targeting a specific location on our targetable object, and this offset will just give us a way to more fine-tune the actual target position. And I'll remove these methods since we don't need those. And I guess the only thing that we need, again, using this offset, is to actually get that target position. So I'm going to make that get target position, I'll call it. And we're returning a vector 2, which is the spot we want to target. And I'm going to use the method called, I think it's called, let's see. Okay, so it's transform point is what it's called. Because I want this offset to take into account orientation. So if our player was orientated, I always want it to be aiming at a specific spot in the chest. So this will take into account the rotation. Because I could just do transformed up position plus offset, but that would not take into account orientation. So I'm going to do it something like this. And that's all that we want for the targetable class for right now. And the next thing I'll do is actually add this to our player object. So I'm going to jump to our player prefab and add this targetable class. And I'm going to leave basically all these the same, but I'll again make the offset different. And I want the offset to be around where this arm pivot is. So I'm just going to say make the offset a Y difference of 1.375. And that should target right around that arm pivot. Because default, our origin of the player is actually at the foot, and we don't want it to be targeting at the feet of the player. So that should be good. And then, so we have now this targetable class. The next thing to do is actually find the targetable objects and actually target them with our player. So I'm going to create another class, and I'm going to call this one target finder. So I'm going to create class and go to scripting. I'm going to call it target finder. I could put this in the player scripts, but I think it'll be just a general script for anything that wants to find targets. And like I was saying, in this class, all we want to do is find the nearest target and then actually rotate to target that object. So the first thing to do is actually find that target, and I'm just going to create a function called getTarget. So I'm going to have it return targetable and call it getTarget. And this function, just the job of it is to find the nearest target. So what I'm going to do is do for each targetable, call it target, and then we have to find all the components with this targetable type. And I think Unity has, changed this a little bit since I've used it, and I think it's find objects by type. And we'll give the targetable, and I guess it wants a sort mode, so we'll give it a sort mode. Find objects, sort mode, and I guess we'll just do no sorting since we're just going to be doing the distance calculations ourselves. So this is going to be looping through each target, which is what we want. But now we actually want to first make sure that this target is within that range attribute that we specified. So that's going to be a simple calculation. We just need to get the distance between the target and us. And I'm going to call this diff. And so we'll get the target and we'll get the position of that target using that function we created. And we'll subtract our own position by just getting our own transform and minusing the position. And this, I think, is complaining because we have to convert this to a vector 2, which is good. And then the next thing is to actually get the distance. And this vector 2 has magnitude, but I'll actually use square magnitude because then that way we won't have to do the square root function, which can be a little costly, but not that big of a deal. So I'm going to do square magnitude, and we want to check if this is less than that target range. And since the range isn't squared, we'll have to square it ourselves. So we're just checking if it's actually within that target range. And if it is, we'll have to then now check to see if it's the smallest target or the closest target. And to store that, I'm going to actually create some variables up here. One targetable called the closest target. And this will just track our closest target. We'll set it default to null. And then the other one, we will keep track of the closest distance and keep updating to find objects that are smaller than that closest distance. So I'm going to say something like min distance, min dist, and we'll set it to default value of infinite. That way, all objects less than infinity, which will be any number, we'll start off collecting that. So now I'll do the actual check of making sure if this minimum distance is actually less than this square magnitude. Actually, I kind of got it reversed. So we'll do the distance. If it's less than this minimum distance, now we actually want to make this targetable object the closest target. So I'm going to say closest target equals target. And also just update this min distance. So that should be finding the closest target. One thing we have to do now is to actually, at this end of this loop, we have to return the closest target. And that will be returning from the get target. We haven't implemented priority or anything like that. I'm just going to leave it like this for right now. And the next thing I want this class to do is to actually use this target it got and to actually target the object by actually rotating to the target. And when I'm saying rotating, I want the arm to be rotated in a straight line to this target. So the arm has just a rigid body component, and since it's a rigid body component, we want to update actually this on fixed update. So I'm going to be using the void fixed update to actually update the orientation. And we'll need to get a reference to this get target. I'll just call it here, get target, targetable, target equals get target. And well, firstly, we want to make sure if it's not null, as it's suggesting, because if there's no targets in the scene, this will obviously return null since there's nothing in the scene. So if it's not a null target, then we actually want to target it. And we'll do this by rotating this rigid body that we're attached to. So I'm going to create a reference to this rigid body. I'm going to say public rigid body 2D, and I'll call it pivot. So this is just, in our case for the player, this could be the arm pivot that we're aligning to. And I'm just going to continue with using rigid body, but maybe in the future I'll just make this more generic by using a transform, or to actually be able to switch between the two. But for right now, since we know that it's going to be a rigid body, I'm going to continue with that. And so now, yeah, we want to calculate what rotation this rigid body should be to actually align directly in line with the target. And the way to do that is actually just using some trigonometry. And the function that we're wanting is the inverse tangent. And Unity has that in its math library. So I'm going to call that. So I'm going to say float target rotation. And then that equals, again, this inverse tangent function. And this takes in basically your vector components, the y and x, and this is just going to be the difference of our, since we don't have difference reference, we'll actually have to calculate again, which isn't that bad. So I'm just going to calculate it again here. And again, so we it takes in vector components for this inverse tangent function, and this is just going to be the difference, that vector difference between us and the target. And it goes y first component and then the x component. And one thing to note is this is going to be in radians, and since I'm going to be updating the rotation in degrees, I'm just going to convert that to degrees, and Unity has the radian to degree conversion factor. And so we have our now targeted rotation. The next thing to do is actually set the rotation of this rigid body. So we can just do something like pivot dot rotation just equals the target rotation. And that should actually just calculate, set the rotation to that target rotation, and that should be fine like that. I think this is enough to actually test this out. So let's go jump back into the scene, and if we click play, let's see if the arms rotate correctly to the nearest player. Well, actually, one issue is I forgot to actually set this to the player. So I'm going to open up this player prefab again, and add this new target finder class. And again, it wants this pivot, which is a ridge body. And this is going to be our arm pivot, which is this hinge joint that we're interacting with. So I'm going to assign that reference there. Now, if we click play, we should see it attempting to... Okay, so it is seeming like it's doing something with the transform. The first thing I'm noticing, it's a little glitchy between updating the physics and actually updating our rotation. And I think it's because it's kind of, I don't know, battling between the physics and our actual fix update of the rotation. And one way to combat this is actually to have the physics not update its rotation values. And I'm going to do that by actually setting the constraint on the rotation. So I'm just going to create a function here and maybe call it public void activate finder. And this is just when we want to actually have this arm start targeting. And one thing we want to do, as I was just saying, is make a constraint so we don't update the actual dynamics of this hinge joint, the rotation of it. So constraints, and I believe it's rigid body constraints D, and then I'm just going to freeze rotation. So that way we won't be actually battling against the physics system. And at start, for right now, I'm just going to activate finder by default, something like that. And let's see if that is a little bit better. There might still be some issues that we're not taking account. Okay, so didn't seem to change much. So the rotation is, okay, so I think I actually know what the issue is. So the rotation seems to be pointing nowhere or just up and down, which is not what we want. And that is actually probably because we don't skip over ourselves. So we're probably targeting ourselves. I could debug this, but I know players have the targetable component themselves. So we just want to skip targets that are ourselves. And the way to do that, or how I'm going to do it, is just to, at the beginning of this for each loop, check if this target is ourselves. So if target, and I'll just create a reference to ourselves up here. So private target, targetable, our target, and I'll just set our target to get targetable. So we're just getting our own targetable component, and we just want to check if target equals our target. And if it is, so if this target component is our own target component, we just want to not return, but continue and skip to the next target in line and then check that. Okay, so now let's check if it's actually working to ignore our own target. And seems somewhat working. It's pointing the arms maybe a little bit too high, but yeah, it's definitely like updating to this position. One thing I'm also noticing is that when it's facing left, it's still not orientating the arm the correct direction. So I'm going to fix that first, is to make the arm actually take into account the scale, because right now when the player actually inverts its scale, when it goes from 1 to -1, flipping the direction, this arm pivot then has to actually flip its rotation as well. I was thinking about actually just changing the setup to actually have the arm pivot not be a child of this body object, so it doesn't have this scale change. But I think I'm going to keep using the setup and then just set it in code. So we just want to make sure if we're facing the other direction, we want the distance to be kind of inverted, the, the difference. So to get the scale, I'm going to go, let's see, what should I do for getting the scale? I guess for right now, we know that it's going to be that first child. So I'm just going to say float scale x equals transform like a child. And we know it's going to be the first child. And we're going to say local scale and dot x. So this local scale is going to be 1 or -1, and if it's -1, we kind of want to invert the distance or the difference. And I believe it will work if we just multiply this whole difference by the scale. That way it will invert the whole difference. Let me check if that works. But we're also might be facing other issues because it seems like, okay, but it does seem like it's working that now when the player is facing the other way, the arm is facing the correct direction. But there's still one issue that I'm seeing is that the player seems like it's targeting maybe something too high. Let's see. Maybe that's because I set the targetable component to be too high of an offset. Let me check. So we have this targetable offset. Seems like it's the correct amount, which is that arm pivot location. Let me just pause here actually and to just kind of debug this more. I'll be right back. Okay, I figured out the error after just looking at the code a little bit more. And the reason why is to actually change this difference function. Because I noticed it was like, it looked like it's just always pointing a little up. And that's because, again, if I navigate to our player prefab, the origin of our player is at our feet. So it's calculating the difference from our feet to the target. So it's always going to be pointing up. We actually want to calculate the difference from that pivot object that we reference. That way it'll be always calculating the difference from this pivot to the target, and it should be what we want because it's actually where we're rotating from. So instead of doing our own transform dot position, we'll do the pivot dot position, and we'll actually do this as well for the down here, the pivot. Now we'll just give it the transform dot position. And I guess since this is the rigid body component, we'll leave it like that. Just get rid of the vector 2 for that. So yeah, now this should be actually be calculating from the pivot location, which is actually what we want since we're rotating from there. So now let's check if it actually is correctly orientating. Okay, so now it's looking like it's pretty spot on, where it's always in line with the target, the closest target. And we only have one target right now, so it's always going to be pointing toward that target. But if I do run away from this player, well, I died running away, but if I do get far enough, it should stop targeting. And yeah, that's approximately what we see. So the next thing that I would like to do is to implement this system a little bit more with actually our power-ups. Because in the game, the original game, we don't have every power-up target the closest player. It's only weapons mainly target players. So we want this actually to be functionality that is dependent upon the power-up. So I'm going to go to our script, and I'm going to navigate to this Powerup item. And this is where we define all the, I don't know, variables about the Powerup. And I'm just going to create another variable here. And it's just going to be a public bool. And I'm going to call it target, maybe. Yeah, that seems fine. And this will be a bool that is basically, if it's true, we want it to target the nearest player. And if it's false, don't target players, just have the arm normally rotate as usual. And so the next thing to actually do to implement that is to navigate to our player Powerup. Player Powerup, because this is where we're handling new Powerups that we create. And we have a function here called create Powerup. And this is where we can actually handle setting this target finder on or off depending on the Powerup, or depending on Targetable. So if Powerup is target, so if we want to find the nearest target, I'm gonna actually, this variable is named probably not the best. Maybe I'll change it to something like find target. Maybe that's a little more appropriate. So if we're finding the target, we want to, get the component of target finder. And now we actually haven't created methods in this target finder class. Well, we created the activate finder, but we should actually just have another method to disable it. And actually, I'll just use this activate finder function, and I'll create just a little Boolean variable if it's active. So if it's active, again, just do what we were doing before, set the constraints to freeze the rotation. And otherwise, we want to go back to the normal constraints, which is just the no constraints, so none. And one other thing that would be nice is to actually, when we're not enabled, to not call this fix update function. We could disable the actual component. Actually, yeah, that probably is better. I was thinking about doing just a variable up here and calling find target or something like that. But I think actually disabling the whole entire component would be nice. So I'm going to do something like this, which is just a reference to this component, and setting enabled to active, which is just a bool if we're active or not. And yeah, I can actually make this a little more tidy, and yeah, that should be enough. So I'm gonna, by default, just remove that from the start, and I guess by default we want this target finder to be off. So I'm gonna navigate to the player and jump to the player component, and I'm just gonna disable this target finder script, and it should be disabled by default now. And we haven't fully implemented this yet, so we want to get this target finder component and call that function now, which is, actually I kind of forget what we called it, activate finder. And in this case we want to set it to true, but in general we can actually just set it to this find target boolean, so something like that. Yeah, that should work. And yeah, let's now test to see if the Powerup only gets, or the target finder only gets activated with the Powerup. One thing I should do before that, though, is to actually change these Powerups to find the target. So all of them are going to be target findable. And now let's test if it actually finds the target when we collect a Powerup. So I'm going to get a power-up box, and it does seem like now the target finder is activated and working. The next thing to do is actually to, once we fully use our power-up, to actually deactivate this target finder, because right now it's continued to find the nearest target, which is not what we want. And from the last video, we have this on depleted, and this is basically when the power-up is being disabled. So this is going to be a good spot to actually disable the target finder. And okay, well, first I'm going to set this to false. And this is maybe something that we can refactor to avoid some bugs, because at the start of the video, I had to add this controller equals null to make sure everything gets reset. But this would be something that, again, I would have to put in this on disable to make sure that this target finder gets reset as well. But instead of duplicating this code, I'm just going to create one function and maybe call it reset powerup. And I'm going to copy basically these two lines, which are the lines to just reset our script in the powerup. And on disable, we'll call reset powerup here. And this is using Boolean. It was just for actually the input, so I'll just leave that how it is. And I'll jump back. So now we should be able to see that when we are done with the power up, we should no longer be targeting. So I'm going to collect one of the power ups. I'm going to use it. And we still are targeting. Let me double check. So we disable, set that to false. If I go to the target finder, disable there. Oh, okay. One thing I forgot is actually to call this function from the on powerup depleted as well. So now it should be calling. So now if I use a power up 3 times, okay, you can see once the power up is depleted, it basically goes back to a normal arm, which is just rotating. Okay, so that whole system, it works fine, it looks like. Let me check what is next to do to kind of make this more complete. So one thing, thinking through, we didn't fully implement this targetable, so this priority float, which is actually pretty easy, so I'm just going to jump to this target finder. And the idea for the priority was, I was just thinking some sort of simple multiply to this kind of distance function work pretty good. So if I do something like this, we'll call it distance value, and this is just going to be again this distance, and then multiply by this priority amount. Again, this is on the target. So something like this. And so we want this distance value to be minimized. So instead of actually multiplying, we want it to divide, since like a higher priority would make this distance value smaller, and we're collecting the smallest values. So something like that should be better. And I'm just going to change this to min dist value. since it's going to be calculating against this value and something like this. So now this finder function is actually taking account this priority, and right now we're just simply dividing the distance by this priority, so that should be simple effect. Just thinking through it, this is squared, this is not squared, so that could be a little weird if it's kind of prioritizing distance a little more than the priority. I think it's fine for right now, but in the future maybe we can look more at that. But yeah, now it seems like this is kind of everything we'd want for a simple target finder. Basically, we have power-ups that are able to target the nearest players, able to shoot. I'll just do one more fix, or not fix, but one more small change before I end this video. So right now we're calling this find objects by type. And we're doing it every, we're doing it every fixed update, which is a lot of times per second. And this can be a little costly. And I'm actually going to go ahead and optimize it just a little bit. You never want to optimize too much right away, especially if you don't need it. But in this case, it's just a small change that will make things a lot better. So I'm just going to create public static targetable. And I'm going to make this actually a list. So what I'm doing here is instead of using the Unity engine to find all these targetable objects, I'm just going to create a static list myself to keep track of all these targetable objects. And I'll just call it like instances. So these are all the targeted instances. And let's see. So we have to import the correct framework there. So the next thing to do is actually make sure we're added to the instance. So I'm just going to say start instances. Well, I think we'll have to initialize it. Maybe we can initialize it in line. Let me check. Something like this. I think that would be fine. But what I want is to actually add this every time a new component is created. And on destroy, we want to remove the instance from this list, something like that. So basically this instances is just keeping track of all the active objects, but it's a little, I think, better than actually doing this find objects by type. But maybe I'm wrong, maybe this is a premature optimization. But basically from this, then we can actually do something like using this targetable at instances, and we'll loop through all those instances. In the future, it might be better to actually create a whole new class, maybe called like Target Manager, that handles kind of this whole target finding and keeps track of all these targetable instances. But right now, I think it's fine to have these like two simple scripts to do target finding. And the last thing I'm just going to do is to test if this change worked. Okay, so it seems like it's working. And I guess one other thing that before I end this video that I notice is when a player dies, it shouldn't be targetable. So, and what I'm saying shouldn't be targetable is that ragdoll component. So if I shoot this player, we shouldn't be targeting this player anymore. And actually, it's not targeting the ragdoll, it's targeting that actually deactivated script. I just noticed that it hit that. Oh, I guess these are still not, you can still collide with these. Okay, I'll have to make sure that actually is changed as well. I'm pretty sure that's with the gun component. But anyways, so we're actually still targeting the deactivated object. So when we shoot a player and kill it, we're targeting this object right here, which is deactivated. So if I drag this something like this, you can see our player was targeting that component over there, which is not what we want. So I'll do a quick fix for that. And this will actually be on this player die function. We want to deactivate our targetable object. And currently, we don't have any method to actually mark us as deactivated. And there's multiple ways to do this. We could remove ourselves from the list and then just add ourselves back on spawn. That'd be one way to do it. Yeah, I'll go with that for now. We can always just change that in the future. So this will be a simple fix of saying something on enable, add this component, and on disable, remove this from the instances list. This way, we'll never be able to target components that are disabled or game objects that are disabled. So if I shoot a player multiple times and pick up a gun, we can see that it's not targeting anything. And then it finds the target once the player respawns. And if you shoot it again, yeah, it kills the player and only updates the target when player is respawn. Okay, so that's what we want. And then to end the video, I just noticed there was a small bug with that gun component. So I'll just do a small change to fix that. And that was in our prefabs weapons. So I think the fix for that is to actually have this ignore mask to also include this ignore raycast as well. The Unity raycast system automatically ignores the ignore raycast layer, but since we're manually setting the layer mask, we have to make sure we actually do it ourselves too. And maybe a better fix for this is actually to automatically update this layer to have the ignore raycast, but for right now, that should be good enough to actually be able to shoot through the ignore raycast layer. Okay, so that should be everything for this targetable finder, this target finder script. And at this point, a lot of the core components of Getaway Shootout is implemented in the game. Mainly like all the player movement and the player weapons are implemented. One thing I'll do for the next video is actually to implement all the Getaway Shootout power-ups and weapons into the game. So we'll have a full collection of all these power-ups. And I'll just do it behind the scenes in the video because it would be a little long if I added each one. And from there, I'll do kind of just maybe a recap video of everything I added and kind of an intermission, because I think it would be a nice stopping point to actually show you different routes that this game could actually go, because it doesn't actually have to be a racing game to race to the finish. You could actually take this game to be very different mechanics and actually have it to be like a brawl game or some other sort of game that uses these player movement, or even like switch up the player movement and kind of do things your own way. So there's many options that it can go. And so yeah, next video I'll kind of recap everything and kind of show possible routes that you can go with this game. And then after that, we'll continue to actually finish the core version with the waypoints, computer movement, and yeah, that should be a wrap of the core game. So I'll see you in the next video. Thank you for watching.